this video, I'll show you how to solve the ALEKS problem called Solving Applied Dilution Problems. There are two versions of this problem. I am going to show you how to solve both versions in this video. We're going to start with the version of the problem that has to do with cell growth, and then I'm going to also solve the version of the problem that has to do with the concentration of two lakes. So this is a dilution problem, and that means that we're going to be using the dilution equation, which is M1V1 equals M2V2. Now there are different variations of this equation, so you might see it as MIVI equals MFVF. You might see it using C's instead of M's. That's fine. It's all the same thing. In this equation, the M1 and the V1 represent the initial molarity and the initial volume of the solution, and then M2 and V2 represent the final molarity and the final volume of the solution after it's been diluted. I love the dilution equation, M1V1 equals M2V2. One of the things that I love about it the most is that it doesn't actually matter what units we use for concentration. Even though it does say M, we don't actually have to use molarity here. We can use any concentration unit that we want as long as we use the same unit for both M1 and also M2. And the same is true for our volume. We can use any volume unit that we want as long as we use the same volume unit throughout. That's going to make this problem a lot easier to solve because ALEKS is being really tricky by using sort of non-standard units like milliliters instead of liters, micromolar instead of molar. If we use the dilution equation, we're not going to have to do any of those metric conversions. So in this version of the problem, the cell growth version of the problem, we have three numerical values provided to us in the problem, and that represents three of the four variables in the dilution equation. We just have to get each numerical value assigned to the correct variable. So this is telling us that we have some sort of thing that has an initial volume of 92 milliliters, that's our V1, and it has an initial concentration of 95 micromolar, that's our M1, and then something happens and the volume changes. The volume goes down to 5.7 milliliters, and we're being asked to calculate the new molarity, that's M2. So we're solving for M2, we're trying to figure out M2 using this dilution equation. And that means that I want to rearrange the dilution equation, divide both sides by V2 to isolate that M2 variable. And I can go ahead and plug in my value of M1 is 95 micromolar. My value of V1 is 92 milliliters. And my value of V2 is 5.7 milliliters. And you can see here that as long as I use the same unit for both of my volumes, that unit is going to cancel out, so it doesn't really matter what the unit is. Now the answer that I get is going to have units of micromolar, and that is the unit that ALEKS wants for my answer, so that's going to work out perfectly. I'm going to carry this math out on a calculator that I have off screen. 95 times 92 divided by 5.7 is 1,533 micromolar. It looks like ALEKS wants this to 2 sig figs, so I have to put it in scientific notation, 1.5 times 10 to the third micromolar. This is the easier version of this particular problem. Let's go ahead and take a look at the lake version. This is a harder version. Now this is still a dilution problem, so we are still using M1V1 equals M2V2. The thing that's going to make this problem trickier is that we only have two numbers provided to us. And in order to use this equation, we need to know three of these four variables, but currently we only know two. That's okay. I've got a trick to help us get around the fact that we only know two variables, but it is going to take a little bit more work. So this problem actually, like if you watch my videos, you know that I usually don't read the problems. I usually don't really care what the story is. But this problem, I think it is kind of helpful for us to take a look at exactly what's going on here. So this is saying that we have salt water, we have salt dissolved in water in one particular lake, and it has a concentration. So this is one of our molarities or one of our concentrations of 64.4 grams per liter. And then there's also other lakes nearby that have a concentration of 4.1 grams per liter. And it's telling us that in this lake right here, so in Lake Parsons, in this lake right here, the concentration is higher because water has evaporated from it. So this right here, this 4.1, this is like our initial molarity. This is what it was. And then a bunch of water evaporated, and this is the molarity that we now have. And the problem asks us to calculate not how much water evaporated. It's also not asking us to calculate what the new volume is or what the original volume is. It's asking us to calculate what percentage of the water evaporated. So it's not looking for a V2, it's looking for like a relationship between V1 and V2. And that's why we're able to use this equation, even though we don't actually know what any of the volumes are. Okay, so like I said, this is a trickier version of the problem, so just, hang with me. This is our initial molarity, and this is our final molarity, and we don't know what the initial volume is, but what we can do, and what I like to do in situations like this, is just assign an arbitrary value to that volume. Now, if that feels really uncomfortable, just keep watching. It'll make sense to you as we go along. So I'm just going to say, let's just assume that our initial volume is, I'm just going to pick 100 because that's a really easy number to do math on. So I'm just going to say, let's assume that our initial volume is 100. And now what we need to do is figure out what our new volume is. So I've got to get everything assigned correctly. I'm trying to solve for V2. So that means I want to divide both sides of this equation by M2, right? So I'm trying to solve for my new V2. My initial molarity, that's this one right here, my initial molarity is 4.1 grams per liter. My initial volume is this number that I'm assuming is 100 liters. My final molarity, my M2, that's this 64.4. And remember, with this M1 V1 equals M2 V2 equation, remember I said it doesn't matter what unit you use as long as you're consistent. So my molarity units being grams per liter, it's not molarity, but my concentration units of grams per liter, that works out perfectly fine. And because those units cancel, and I am going to now solve for my V2. 4.1 times 100 divided by 64.4, my new volume is 6.366 liters. Now that is not the answer to the problem because ALEKS is not asking us to calculate what the new volume is. ALEKS is asking us to figure out what percentage of water evaporated. So in this imaginary situation that I have created here, I started with 100 liters of water, and then it evaporated, some of it evaporated, and I ended with 6.366 liters of water, and I'm being asked to figure out how much actually evaporated. So the amount that evaporated, the evaporated volume is going to be the difference between what I started with and what I ended with. 100 minus that is 93.6. We're just going to leave it at that, 93.6 liters. So this is how much evaporated. The amount that evaporated is 93.6. And ALEKS wants us to calculate, again, not this number. This is not, it doesn't want to know exactly how much evaporated. It wants the percentage of the original volume that evaporated. Now, because I chose to use 100, because I always choose to use 100. This is going to be really easy for me to do the math on. The percent that evaporated is going to be the actual amount that evaporated, divided by the original volume. And then we need, because it's a percent, we're going to need to multiply by 100. I'm really squeezing it in there. The amount that evaporated is 93.6 liters. The original volume I picked was 100 liters. We're going to multiply that by 100, and that's going to give me a percentage of 93.6%. ALEKS wants it to 2 sig figs, which is 94. This is a tricky problem, but it's gonna be okay as long as you start with a pretty simple initial volume. The hardest part about this problem, I think, is getting my M2 and my M1 and my V1 in the right spot in this equation. So just be really careful with that.